Hello. Okay, so I did something terrible. I want you to be very, very aggressive problem solvers. I want you to throw yourself at the problem like there is no tomorrow. And one thing that I have to provide for that is that I never give you problems where that we didn't cover together. Basically, you have to know that you have to have faith that my teacher wouldn't give me this problem if I didn't have all the tools. And this is a very sacred thing for me, very, very important. And I unintentionally violated it, and I put stuff on the exam that we didn't cover yet. So I want to apologize for that. I want to say, I hope it never happens again, but I get worse every semester. Let's just take care of that stuff that I accidentally put on. I withdrew it. So you didn't get penalized for it. I think everyone got maximum point for those, but still it can demoralize you during the exam. So it's not like it never happened. And that problem was something like this. Well, let me start with the theory first. A circle. What's a circle? Circle is the set of all points in the plane equidistant to a fixed point. Let me ask. We didn't do sets. Did we do sets? We didn't do sets, right? I checked no, we didn't cover sets. Okay. So a circle, you fix a point in the plane and then you fix a distance. Imagine that, well, this is called a compass. This is a compass. And you open this you can move around. And with a fixed distance, we go around. That's what a circle is. It's the set of all points equidistant to a fixed point within the plane. You take out in the plane, you get the sphere. Now, what I want to talk about today is the idea of set. Because everything is defined in terms of sets, everything. There was a very smart guy who early on discovered that the way we define things is we grab something that's already known and we specify it. Like a square is a special case of a rectangle where each sides are equal. Okay, what's a rectangle? Well, a rectangle is a special case of a parallelogram. It's a parallelogram with right angles. Okay, what's a parallelogram? Well, it's a four-sided polygon with two pairs of parallel sides. Okay, but what's a four-sided polygon? And so on, and so on, and so on. So this one really smart guy realized that there has to be one thing, just one thing that we accept without definition. Otherwise, we can't, if nothing is known, we cannot specify something known to create a definition. And that thing that's vaguely, if at all defined, is the set. That's how fundamental sets are. Everything is set. Even the numbers 1, 2, 3, 4, when we rigorously define them, they turn out to be, those are sets. Everything you can think of, and a few more things in mathematics, are sets. So the definition is kind of vague. A set is a collection of objects. Those objects could be numbers, letters, little flowers, other sets. You can shove a set into another set. So it's really relaxed. It's just a collection of things. Usually we use capital Latin letters for sets, and then trying to weave through this fairly quickly because we have other stuff to cover today. There are all kinds of notations. How do you specify a set? Well, if anyone can decide whether, if you can look around in the universe and for every object, you can decide whether it's in that set or not, then the set is well defined. And there are several ways to do that. We could say, let A be the set of people on this Zoom, or we can just, we can say 1, 2, 3, 4, 5. This is what makes it a set, these little braces. And then sometimes we can write things like this dot, dot, dot means you got the idea, now don't stop. So that goes on forever. These are all legitimate ways of giving a set. Now, there are reasons to think yes, there are reasons to think no. The question is, and this is not a matter, this is a matter of agreement. Are these two sets equal or not? What do you think as sets? It turns out these two are equal. Repetition and rearranging the objects in a set. It's basically, is the number 2 in your set? Yes, yes. Is number 1 in your set? Yes, yes. Is number 3 in your set? Yes, yes. Is number 5 in the set? No, no. So if you get the same answers, the two sets are the same. You can't have duplicate. So these two sets are equal. So repetition or order does not change the identity of a set. Oh, I forgot the most important way we denote sets. We love these diagrams. A bubble. I'm going to make this circle into a set. No, it's too big. So this set A has 5 elements. It has 1, 2, 5, -13, and capital B in it. Capital B could be a point from geometry. It could be another set. So 5 elements. We love these pictures. Oftentimes, and this is what you needed for the exam. There is this brilliant problem-solving tool called Venn diagrams. I think it's named after a dude named Venn. So let's say that U is 1, 2, 3, 4. Now, this is all the numbers, positive integers between 1 and 10. Capital U stands for the universe. So usually the universal set, this is the universal set, declaring what is the universe for this problem. So within the context of the following problem, nothing else exists, only these 10 things. So it sort of declares this is the universe. And then let's say A is, well, A is 1, 2, 7, 9, 10. And B is 1, 3, 5, 7. Okay. Now I'm going to do a Venn diagram. And the idea about the Venn diagram, there are two sets here, sets A and B. So the rectangle, this is the world. The universe is pretty small. And the idea is if you want this to be a Venn diagram, you have to write down every number from 1 to 10, but only once. So for example, what do we do with number 7? Number 7 is in set A, and it's also in set B. By the way, there is notation for that. 7 is an element of, sometimes you see this symbol on guitars, Epson guitars, or like the Russian letter for E. It means element of, belongs to. That notation was on the exam, shouldn't have been. So 7 is an element of A and also an element of B. This would be wrong. What we do instead is we say, well, there is a region that's sort of inside both bubbles. You see, this is inside A, this is inside B. So as long as we stay here, now you can see 7 is inside A and also 7 is inside B. There is a little bit of combinatorial side note here that there are 4 possibilities. The object can be in A or not, same with B. So an object can be in both, in neither, only in A, only in B. You had this with the true, false things, right? So we have these four basic cases, and there are 4 regions. This is where we're gonna put everybody who's in both sets. This is where we're gonna put things that are only in B, but not in A. Similarly, only in A, not in B. And these are the, I call them the floaters, the free floating objects that are in the universe, but not in A or B. All right, that said, where can I write 1? So we're gonna start writing, I go by 1, 2, 3, 4. So where can we write 1 in this diagram? You know, I usually call it overlap, and I bite my tongue because there is going to be an operation between sets that creates exactly this. So it's called the intersection. The intersection of A and B is going to be the stuff inside. It's the stuff, it's a set formed of only the things that are in both sets. So one goes into the overlap or intersection, as it later will turn out to be. How about two? Where does two go? Floater, only be both. Only A. Good. Oh, I wrote A. Good. What about three, the number three? Where does three go? Three goes in B only, because it seems this is the region for things that are in B but not in A. Four, where does four go? Yep. Five. Five is gonna go inside B, outside A. Six. Yep. Seven we did. Eight. For the recording, I keep getting the correct answers promptly in the chat box. You guys are on it. You know your exam one was the highest. Oh, I'll check on that, but it was pretty good. It might have been my all-time highest average, maybe not just even in this class, but overall. So you guys are a really strong group. 9, where does 9 go? 9 goes into the intersection, and then 10. Yes, okay. Now, so I go by, basically, I just list all things that exist. That means by the element of the universal set, and decide who goes where. Here is how I check. First, try to ignore everything. Just focus on the rectangle. Inside the rectangle, we should see 1 through 10. Do we? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And not just we should see everyone. We shouldn't see them more than once. Everybody should be there just once. And then, now it's a little bit trickier, but try to ignore everything. Just focus on this bubble. Imagine that we erase this. Do we see the things that should be in A and only those things? 1, 2, 7, 9, 10. Yep. Same with B. 1, 3, 5, 7, 9 is what B is. So then we're good. We checked for U, A, and B. This is a Venn diagram. This is how you complete it. And it's a very, very, very smart problem solving tool. So fundamental. Set theories, you know, this stuff used to be covered in pre-algebra. And then we took it out from pre-algebra a long, long time ago. And we just, I don't know, we just pretend or ignore. We're in denial. We kept saying is the set of all things, but never define sets. It's terrible, terrible. So I massaged it back into this class. You need to learn about sets. All right. So suppose I lost my numbers. I'm gonna have to make up my numbers again. Aha. So suppose we ask 50 people about their pets. And imagine that the interviewer does not let them talk a lot. It's a yes or no questions. And basically they ask the students, these 50 people, do you have a cat or cats? Yes or no. Do you have a dog or dogs? Yes or no. And so here are the results. 28 people has cats, cat or cats. 34 people has a dog or dogs, and 18 has both. How many have no pets? A problem like that was on the exam, and it had no business being on the exam. So I just want to make sure. Okay, so if we add these numbers, it's definitely, if we add the first and the second, it's more than 50. Is that wrong? Is something off? This is not a possible result? For the recording, there are crickets in the chat box. Right. But how is that a problem when we have 50 people? We asked 50 people and we got these answers. Isn't it a little too much? Some of them have both, and those were double counted. And a Venn diagram sorts this out beautifully. So here is the problem here. The 28 who have cats also are included here, right? They said yes for cats. There was not a separate question for both. So basically, we're going to fill out a Venn diagram. And if it's possible, always start inward. Start with the intersection. Cats, dogs. All right. And this rectangle, the numbers inside should add up to 50. That's the universal set. And now let's start from the inward. In the intersection goes all the students who have both cats and dogs. That's 18. And the real big deal is that now we're not going to write 28 here. What number are we going to write here? Exactly. We have 28 people inside this bubble, but we have already, no, not 28. We must have 28 people in this bubble, but we already put in 18. 18 are already there. So we just say, right, and now we can kind of sort out, okay, there are 28 people who have cats, 10 of them only cats, and 18 of them cats and dogs, right? Again, the Venn diagram is very, very smart. Such a basic and such a smart thing. What number can we put here? Exactly. So yeah, we have 34 dog owners, but we have already accounted for 18 of them. Subtract 18 from 34, we get 16. And we still cannot answer yet the question, which is how many have no pets? But maybe we could, because these can now be added. And if we add it up, however much is missing from 50, that's the people who have neither. So if we add it up, that's a little much. 24, it's 34, 46 of them. Add up all these three numbers. These are all different people. We have accounted for 44 people, but we asked 50 of them. So 6 of them. Now, if we add these 4 numbers, they add up to 50. These are the ones who have neither. These 10 people have only cats. These 16 people have only dogs. And these 18 people are proud owners of both. I don't know if you recognize the problem that was on the exam that had no business in it, in being on that exam. And then there could be questions like, how many people had only one type of animals? One species. Exactly, 10 plus 16, so that's 26. How many people, how many people have cats or dogs? Ooh. And that's not the same as the previously. This includes the both. So this is the mathematical OR, not the American OR. That means cats, dogs, or both. Not 26. You're not understanding. The point is that the word or in mathematics means one or the other or both, not one or the other, and there is no in between. It means just one, just the other, or both. That's what the mathematical OR stands for. Well, I would just say, well, everybody except for these 6. No, it's 44. This is what it means, cats or dogs. It means cat, yeah. You remember, yes, 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 no, no, yes. In an OR statement, those all work. That's all right. That's all right. The first mistake is always for free. Yeah, 44. And then after a while, you get a little slick and you say, I don't need to add all this. I just need to subtract this guy from the but it should be the same, exactly. Okay. How many people had cats but not dogs? No, that was not a trick question. This question is scratching on something important and central, that is the meaning of the word or in mathematics. There's no trick here. The correct answer is in the chat box. Well, how many had cats but not dogs? 10. These 10. All right. I think you can go into your grade book and find that question that was like this. And then now you know what to do with it. I'm sorry, I should never, this is so important for me that I never pose a question to you that you cannot solve given where we are at the problem. You know, I had a math teacher I had a brilliant math teacher, probably the #1 in his country. He was a hotshot at the university. I just ended up in his experimental class. And I could solve all the problems. That was no problem. And then I got accepted to the university and I couldn't solve my first homework assignment. I got so upset. I got desperate. So I took it to my math teacher. I visited him and asked him how to do that. And turns out that what I got as homework was an unsolved, still open question that no mathematician of today can crack. And my math teacher got so angry. He never verbalized what I just told you, that I will never give you a problem outside, but he got really mad. He got angry. And that's when I realized that, oh my God, I never got a problem I couldn't deal with. Because that's what makes you sort of feisty against the problem. If you think, well, maybe there is a theorem I don't know, then why bother? You know, then it's impossible for you to figure it out. So your attitude towards problem solving is very important. And for that, you need to know that you will never be given a problem intentionally that you cannot deal with. Oh, so the question, you never had a problem you could not solve? Oh, I had plenty, but none from my math teacher. None from my math teacher. Nope. Yeah, that's just something, you know, there is a sweet spot. The question should be solvable on your level, but it shouldn't bore you. And in between, a problem that challenges you, but you solve, that's the sweet spot. That's where you should be when you do homework, and then math is not so painful. By the way, I can state you you know, when we think something is true, but it's not proven yet, it's called the conjecture. Conjecture is sort of suspicion in mathematics. The Goldbach conjecture, I'll never forget it now. Conjecture. There is a strong version and a weak version. Let's see, n is greater than or equal than 5. I'm just going to give you the strong version. Strong. Every number, every integer greater than or equal to 5, every even number can be written as a sum of 2 prime numbers. So 6 is 3 plus 3. Even 4 would work, right? 4 is 2 plus 2. 6 is 3 plus 3. 8 is 5 plus 3. 10 is next, 5 plus 5, right? 12 is 6 plus 6 would not do it, but can you find 2 primes that they add up to 12? Actually, that guy who was my teacher at that same university, he got in trouble. I didn't know, but I got him into some heat. He heard some a mouthful from my instructor, my teacher. Hey, 2 primes add up to 12. Don't leave me hanging. Did we not talk about prime numbers? You did. Yeah, there we go. 5 plus 7. That's the one I had in mind. 1 is not a prime, so that's the only one. 14 is easy. 7 plus 7. 16 is 13 plus 3. Okay. the weak version, and so on. We still don't know. We think yes, but no one has proved it or disproved it. The weak version, that every odd number, I'm gonna get again, let's say starting from 7, can be written as a sum of 3 primes. If we have the previous one, then we easily have, because if you can write every odd number, every even number, then just, this is some, every odd number can be written as a sum of 3 primes. Yes, if every, this one easily follows from the previous one. If you can express every even number, then just add 3 to all of them, and there is every odd number, right? So even is prime 1 plus prime 2, and just add 3 to each of them, and you get all the odd numbers up, starting from a, this would be, the 3rd prime is 3. So it's the stronger version implies the weaker version. So that was, see, this statement is pretty simple to state, but proving it, obviously, no one cracked it yet. So there is work to do for you. All right. So it's all about your attitude. It's not who is smart. It's who is more stubborn and shameless to get the answer. Okay. So that was one thing I wanted to make sure that now you know. And then today's, oh yeah. So I teach another class that, oh, you know what, your next class, if you're still undecided or still you wanna pursue STEM, then basically chapter 2 is called intermediate algebra. This is beginning algebra. It's labeled Math 99, and Math 98 and 99 is a course that I try to teach every semester. There are lots of cancellations, but so far I managed. So next semester, if you're still not, well, next semester you can take my Math 99. You will, I don't know, it's getting smaller and smaller. Good, yeah. I'll be glad to work with you. So I teach a Math 99 class, and there was a topic I almost skipped over, and boy, was it like, I was shocked how difficult it was for them. So I expect no better from this class. That's a surprisingly strong group too. It looks like at this point you can get into college level so easily that the people who bother with this level are actually here to learn, not to get the, it's kind of weird that my DevEd classes are my best groups and my college level classes are terrible. So they are not weak either. That's why it was such a surprise. And so I assumed that this might be an issue. All right, that said, I went to gamble. And let me say something before I move on with the math. Gambling is bad for you. It's a terrible addiction. I think buying a lottery ticket is actually buying something. I think you're purchasing a positive probability that you wake up a billionaire. I don't think it's just gambling. I think it's something more. But buying the second lottery ticket is a waste of your money. You double a teeny tiny number, it's not going to get much bigger. And so gambling is a terrible addiction. And the one thing you need to know about gambling is the house always wins. And that means you always lose. So I just want to be clear right from the start that I don't want to encourage anyone to gamble. It's bad thing. But that said, I went to gamble. First, I doubled my money. Then I lost $100. I'm walking out, sadly. I try to make these stories always sad to discourage you. Walking out with 20 bucks. How much did I have at the beginning? I'm walking out with 20 bucks. That's a statement. How much did I have at the beginning? And by the way, this story is phony because people stay there until they're dead broke. They don't walk out with 20 bucks. Okay, I have one shy answer in the chat box. That means only I see that answer, but keep it coming because it's not the correct answer. At least he's talking to me. You know, nothing about the chat box goes on the recording. Okay, so there is an answer in the chat box. Let's check it. So suppose I walk in with 40. I double my money. That takes me to 80. Then I lose 100. That takes you to negative 20. So that's not. No, first I doubled my money. That means if I had 10 bucks, I won 10 bucks. If I had 1,000 bucks, I won 1,000 bucks. I went from a number to twice that number. And then I lost 100. That's what took me to 20. It's not random. Right. So the chat box says I'm not sure, but that's not the same as random. You solve something that you cannot verbalize, you cannot put it in the level of language, but you have the right instinct. So maybe this is not a surprise after my other class, but first of all, I'm glad you're not gambling. Second, imagine that we have recorded this sad sequence of events and we're watching it backwards. So the first thing that you see backwards is me walking out. Well, it would look like I'm walking in with my back towards the door with 20 bucks. What was the last thing that you first see in this backward video that took me down to 20? What took me down to 20? What event took me down to 20? So I'm walking out with 20 bucks. What was the event? How much winning or losing that took me to that 20 bucks? What was the last thing that happened to my money? Come on, there are two things happened. The second one is the last one. Yeah, I shouldn't have told you that it was difficult in the other class because now you're overthinking it. So walking out with 20 bucks. What happened just before that? There's not a lot of events here, but we have to consider them in a reverse order. What was the thing that happened? Exactly. The thing that happened last, the one that took me down to set 20, was a loss of 100 bucks. Kind of reverse that. So where was I before losing 100 bucks? You saw the whole thing now, but yeah. So, but, oh God. Okay, slow down. I'm trying to slow down and now you guys are speeding up. So what took me to, I lost 100 bucks. That took me to 20. So how much do you have to start with so that when you lose 100, you're left with 20? Exactly, 120. If I lost 100 bucks and now I have 20 bucks, I probably had 120 before, right? So then had 120 bucks. And then you can check 120 bucks. I lost 100. I'm walking out with 20. It makes sense, right? Now, what took me to 120? What happened before I lost that 100 bucks? What took me to happy 120? It was doubled. No, we're done with the loss of 100. We did that. We're watching these events backwards. So when you watch it backwards, the last thing happened is what you see first. No, you were fine. So had 120. What number do you have to double so you land on 120? What amount of money do you have to start with so that it will double you up to 120? Once upon a time, I'm thinking of a number, and if you double it, I get 120. What's that number? Yeah, you had it earlier. I was just trying to massage it through the others. $60. And then we can check sort of, okay, $60. First, I won't even look at this. I went to gamble with $60 now, we think. First, I doubled my money. Oh, nice. 60, double it, 120. Then I lost $100, 120 minus 100, walking out with 20. So it checks. All right, that didn't go as well as I hoped it would. Although I now learned what questions to ask, so I'm doing this a little better than I did with the previous class. All right, okay. So the first sentence is always the same. I went to gamble. So first, I lost $200. And then doubled my money. Walking out with $60. How much did I have at the beginning? How much did I walk into the gambling establishment? I love it that we see 3 different answers. Actually, the correct answer is among them. You only see 2 of them. There is one shy, 260. Sorry, I outed you. I outed your number, not you. So what do you think? Oh, there is a 4th. 230, 260, 30. But see, somehow we're sort of undoing things. That's why I compare it to rewinding a video. So walking out at 6, doubled my money to 60. What do we have to double to 60? What number do we have to double to 60? Come on, I'm sending back my teaching degree today. If I can get you to find this. What amount do I double to land on 60? Oh, actually, it's in the chat box. Right, 30. So from 60, well, 60, we arrived to 60 after doubling. So before the doubling, it was 30. And then we're climbing back. Okay, well, I landed on 30 by losing 200. So before that, I must have had how much? 230 is the correct answer. Okay, I'm trying to put notation there, but basically these are what I would call 2-step equations. There are 2 things happen. Okay. All right, let me so how do I write the answer? So doubled to 60 means had 30 before, right? And lose 200 to land on 30. We had 230. Okay, so that's the answer. Okay, let's do one more. You guys are catching up faster than my previous class. So either you guys are better or I'm better for practice. Okay, so I went to gamble. First, I lost. Wait, did we do that? Oh, okay. I lost half of my money. And then won $100. Walking out with $160. Question is the same. How much did I walk in? I'm sorry, I did something wrong. Okay, we'll do this one. How much did I have before I walked in? Oh no, this is what I wanted. I'm trying to make up problems where it's a bad story. I thought I messed up, but I think this is. So walking out with 160, what took me to 160? You know, once I saw that I got 120, but I'm not sure. Let's see, 120. I lost half of my money, so 120 to 60, and then 100, 160. Yeah, so this is a happy story, because yeah, we're walking out. Okay, all right. So the answer is $60, right? Because we double 60. No, wait. What was? Sorry, I'm getting myself confused. Okay, so 160 after winning 100 meant 60 before, and that was after I lost half of my money. To lose half of my money and land on 60, I must have started with 120. Right? So what I don't like about this example is that this person won, and that's not something that often happens. All right, so let's say I lost half of my money. And then won $100. Which is the same story so far. Walking out with $400. How much did I walk in with? That's more like what happens in real life. I got two equal answers. Oh, I think Illinois. Well, last time I checked, it was illegal to gamble in Illinois, but there are boats on the lake that technically are not in Illinois, so it's closer than Vegas. But as I said, don't do it. Okay, is 600? Does that make sense? Let's see, 600. We start with 600. Then we lose half of that. Now we're down to 300. Win back 100, 400. Okay, so the kitty is right. Okay. It's kind of interesting that the events were sort of the same. And yeah, this guy won and this guy lost. And the more money we walk out with, that means it was a big chunk. That the loss was more than the winnings. There are other interesting things going on here. So we're undoing things in a reverse order. Right, that's how we undo things. When we undo things, we undo first what happened last. So we're kind of, you know, I also make this, I don't know if this helps, but let me hide this eraser. So the first thing I'm gonna do is, I'm gonna put this little yellow paper on the top of it. And then I'm gonna put a big black folder on the top of that. So first the yellow folder, this is black. Black. Now, what can I remove first? I wanna find this thing that I hid. What is natural to remove first? It's a philo system or philo system that first in, last out. Yeah, because that's on the top. That's the one. And then now I get to take the yellow paper, and now I found it. So there are two things. We're undoing things and in a backwards order. But I think you kind of got the logic from these examples. Should we do one more example? I won $100 and then lost half of my money. And let's say walk out with 400. This number is the same, the events are the same, but the order was swapped. So walking out with 400. How much did we start with? Okay, 250, 150 is in the chat box. I'm not sure because 150 plus 100 is 250. You double that, that's 500. We're walking out with 400. So it just doesn't check out. Oh no, no. I thought you guys are getting this. Walking out with 400. What took me to 400? I lost half of my money. How do you lose half of your money and land on 400? And then that happened, that number happened after I won 100. So how do you get to that number by winning 100? 600 is not correct, but it's closer. Because if you start with 600 and you win 100, that's 700, and then half of that is 350. I thought you guys are getting this. $450 is way too much, I think. Wait, 450, add 100, that's 550. Oh, 550. Oh, I doubled it. Did I say silly things? 450, add 100, that's 550, and half of 550 is 250 and change. But I'm not sure about the 600 anymore. 600, 700, 350. So 600 is not enough. 450 was too much. 450 is way too low. If we start with 450, these events will take us to 200 something, right? 450 plus 100 is 550. Half of 550 is 250 and change. You know, guessing you zigzag your way there like a Roomba with the walls, but you can just undo those things in a reverse order. If you lose half of your money and land on 400, what number was before that? What number, when you lose half of it, leaves you with 400? No, that's doubling. If you double your number, if you start with 200, then you double your money up to 200 or 400, right? You start with 200 and 200. If you start with 300, 100, that's 400, and half of that is 200. Okay, all right, stop. This is doubled. Oh, I'm sorry, I'm lost half and left with 400. What number did we? If you lose half and left with 400, what number was before that loss? Just prior that loss. No, If you lose half of your money from 600, you would, it's a division by 2, that's 300. Half of 600 is 300, not 400. What number's half is 400? There we go, 800. Yes, you have to start with 800 so that after you're losing half of your money, you have exactly 400. And that 800 was after we won that $100, right? So what number, when you win 100, lands you on 800? I think someone said that number, and I said no. No. So 100 to get to the number 800. Don't tell me what number you need to start with. So after you win $100, you get to 800. Yes, 700. Wow, that was, we did 3 examples already. I thought you guys are sort of getting the hang of it. Yeah, 700. And we can check. Start with 700, 100. Okay, now we're up to 800. Nice. Then lose half of it. 800, half of that is 400. And when you lose half of it, it doesn't matter what you worry about, what you lost or what is left, because it's the same. That's what a half is. Maybe that was the problem. I'm not even gonna get you to harder stuff when you lose a third of it or something like that. Okay, so someone said in the chat box, that's interesting. So this is, I think, I don't know, when you store objects or some kind of logistic, these are 2 systems. This is first in, last out. Imagine way too many people cramming into an elevator with 1 door, right? Then the first in, and then when the doors open again, the last people can come out first. And then first in, first out, imagine an elevator with 2 doors. Like you jam in here, you go downstairs, and then they come out here, then first in, first out. So this is clearly a first in, last out system. It's just a way of things are, I guess, that when you're undoing things, then you're gonna first undo what happened last. Got into, should I do more examples? You guys are, all right, let's do a few more. Okay. Lost $300 and later doubled my money. Walking out with $50. How much did I start with? The wrong answers are much better than nothing. Exactly. So sort of, no, now you're catching up. Good. So walking out with 50, that happened after we doubled something. Well, that's probably 25, because 25 when doubled gives us 50. And that happened, that doubling that took me from 25 to 50 happened right after I lost 300. So a loss of 300 takes me down to 25. That means 325. Exactly. So I don't know, 50, 25 to double. And then minus 300. So that's 325. Okay. And what if I double my money and then lost 300 and walk out? So, okay, I'll write it down. I have no idea what this is going to do. So double my money. Lost 300. Walking out with 50. Same events, it's just the order was swapped. which does matter. Walking out with $50. How much did I have at the beginning? So the answer box says, oh, 325. That's for this one. That was the correct answer for the previous one. This one doubled my money. That's 650 minus 300. That's 350. So this is correct, 325, but 625. Oh, I'm sorry. 325. If I start 650 minus 300 is 250. We're walking out with 50 only, not 250. So 325 checks with this one, doesn't check with that. This recording is going to be as exciting as watching paint dry or grass grow. Just put the wrong answer in there then. Never done that yet. Just watch the videotape backwards. Okay. Oh, if you start with 350, then double my money, that's 700, lost 300, you're walking out with 400. That's not what happened here, right? Yeah, this is supposed to be a 50, but I'll take a correct answer for 20. Well, one good news is obviously you guys are not gamblers, because I think then this would go a little smoother. 150, double it to 3. Okay, 150, you would walk out flat broke, right? Because it doubles to 300 and then you lose 300. So that would take you to 0, not to 50. So you're somewhere in between 350 and 175. 175 might just be the one. Two times 175 is 350. So if I lose 300 from that, that leaves me with $50. So 175 is the correct answer. Now let's see how that happened. A loss of 300 took me to 50, so I must have had 350 before. That's pretty clear, right? And what took me to 350 doubled to it. Well, what number, when doubled, will give you 350? And more importantly, how do you ask the calculator? What do you punch into the calculator to ask what number doubles up to 350? What do you enter? Right. But now I'm asking, but how do you ask the calculator that? What do you enter into your calculator? Your calculator does not have buttons like how much do I have to double to get to this? What operation do you enter to find the number that doubles to 350? Yeah, what's in the chat box? Hang on with that. Yeah, we're going there. 350 divided by 2, exactly. So, all right. If you could channel your confusion into form of questions, this would be a good time for that. Because I'm not seeing everybody perking up here, which you should get this today now, because it's not going to get any easier outside of this class. Because if it was, you would already know this. All right. No questions? Now, the title of this topic is two-step equations. So the first story was I went to gamble. First, I doubled my money. Then I lost. Oh, in my previous class, the class couldn't solve this again. Like, if I asked you solve it now as if it was new, I hope you can. I went to gamble. First, I doubled my money, and then I lost 100, walking out with 20. How much did I have at the beginning? Pretend you haven't seen it before. Try to solve it fresh. How much money do I started if after doubling and then losing 100 left me with 20 bucks? That's what happened in my other class too. Come on now. Maybe I'm no longer online. Am I online? Am I alone in this Zoom room? Come on, we solved this 10 minutes ago. Went to gamble, I doubled my money, then I lost 100 bucks, and now I have 20 left. How much did we start with? 120 doubles up to 240, and then subtract 100, and it's 140. That's too much. We're walking out with 20. See what I did? If we go through these events, starting with 120 to 240 to 140, that's not landing you at the right number, but at least you're talking to me and you're trying. I don't know what the others are doing. Well, check. If you grab that number and double it and then subtract 100, do you get the 20 that's left? All right, that's news because you didn't like it at first. Right, so 20, go backwards. A loss of 100 takes me 20, that's 120. How did I get to 120? I doubled up to it, that's 60. So exactly. So 20, I said 20. Well, that was the last stage. Then it had to be 120, so that after 100, after losing 100, we have 20, and we doubled up to get to 120, so that was 60. Now, notice that in case of a loss, when you reverse the loss, you're sort of adding back that money that you lost. And when you undo a doubling, you divide. So these are inverse operations in a reverse order. Now, let me put this into notation. When I went to gamble, once upon a time, there was a number X. First, I doubled that money, and then I lost 100. Now I'm walking out with 20. How much did I start with? That is a two-step equation because there were two things that happened. So there is lots of things to talk about here. There is the philosophy, and then I need to talk to you about notation too. So you can ask, okay, what happened to the pool unknown? And we can say, well, the first thing, imagine that X is a number. First you would double, then you subtract, right? So first, this number was doubled, and there was a subtraction of 100. We're going to undo them in a reverse order. So what number will leave me with 20 after a loss of 100? To express that, we're going to add 100 to both sides. This is where we promise what we're going to do to the next step. Now, this here that I'm putting to the margin, this thing that I'm putting on the margin for a good reason, you need to let that go. You know, I think of this as the training wheels. Have you ever seen a bicycle champion with training wheels on his bicycle? No, because it slows you down like hell after you learned how to drive the bike. This here is a sad side effect of people who teach basic algebra. They only teach basic algebra. They don't see, I teach from beginning algebra to Calc 2, so I know this stuff is not going to serve you well, not even the next class. So this is the notation that people, you know, afterward, what is the philosophy? The philosophy here is that two quantities are equal. they will remain equal as long as I do the same thing to both sides. So it goes without saying that we're going to do the same thing to both sides, always, always, always. And what things we're going to do to both sides is, well, we want to peel off this 100, we want to peel off this 2. We want to undo those things. Now, the fact that from minus 100 and plus 100 would sort of, you do not need this visual. You do not need this visual. Neither does the reader. 2x minus 100 plus 100 will make this go away. That's why we chose to do it. Now we add the 100. Also, we don't need the visual clue why a 20 plus 100 bucks is 100. None of this you really need. Think of this as we promised what to do, and then this is the result of what we did. You do not have to show how to get from here to here. That's a really big one of the biggest errors in the correct American curriculum. So let this format go. Now, if you don't, will you lose points on the exam? No, but I will make faces when I grade the exam, and then you're going to mess it up because of your format. And then I'm going to say, I told you so. So these are the consequences. You will never lose points for it because it's not that it's a false statement, but I'm telling you, you will be better off if you let that thing go. So we doubled up to 120. What number, when doubling, will give us 120? We're going to divide both sides by 2 to undo this multiplication by 2. Again, 2x equals, I don't think you really need this. This is just going to hold you back. This is cleaner. And I wish I crack open any book beyond the level of beginning algebra, and you will never see this stuff here. This is the stuff. Sometimes they say it in letters, like we will add 100. And it always goes without saying both sides, both sides, both sides. Because what's going on is, well, you understand the logic, right? We have, this is the third time we're solving this problem. This is the same as I went to gamble. First, I doubled my money. That means x to 2x. And then I lost 100, subtract 100. And the result of all that is 20. So to go backwards, you already kind of have the instinctual logic, right? But I'm going to give you another sort of underlying fancy snobbish principle, is that this equation is called a conditional equation, because this equation is true if x happens to be 60, and it's false for any other number. Now that sounds a little strange because it sounds like a declaration. But imagine that x is some number out there and you're guessing. Is x 60? Well, that is sometimes true, sometimes false. This particular statement is only true when x is 60 and false for any other number. Now, as long as we do the same thing to both sides, that will remain intact. This thing is false for all number except for 60 when it is true. And so is this one. So basically, we preserve the solution while making the equation simpler and simpler by undoing the things that were done. So one more thing. Well, you know how to check. We just substitute our number into the scenario. This is short for left-hand side. Oftentimes, the left-hand side is much longer than the other, so we don't carry them together, kind of. Doesn't matter. 2 times 60 minus 100 is 120, minus 100 is 20. That's the right-hand side, so we're good. This is left-hand side, right-hand side. So the left-hand side, 2 times x minus 100 becomes 2 times 60 minus 100. And that is 20, so, okay. All right, so now I think we can let this one go. Is there any questions? Or comments, observations, complaints, lamentations, objections? Is there anything you want to say about this? You're no fun today. I think I'm going to go page 8. Okay. So then the next question This is still solving. Okay. The next one says, first I lost 200 and then I doubled my money, walking out with 60. So how would we write it as an equation? We can say x minus a 200 and then double. This is not saying that. This is doubling first. So you have to put this parenthesis because of order. You have to express exactly what happened, right? Just imagine that x is a number. If x was a number and I asked compute this, you would first subtract because of the parenthesis, right? First subtract the 200 and then you would double it. If the parenthesis is not there, you would double first and then subtract 200. That's not what is described here, right? First I lost, maybe it should be in the frame. First I lost 200, that's x minus 200. And then it was doubled. The then necessitates this, because without parentheses, you would do the doubling first. And now I'm at 60. This is a especially interesting example because people distribute and treat it differently, but this too is a two-step equation. What happened to the poor unknown and in what order? First, there was a subtraction of 200 and then there was a multiplication of 2. We're going to undo this in the reverse order. So the thing that happened last, we're going to undo first, and it's going to be, it's called the inverse operation. So what doubles to 2? That's a division to figure out. And then we're going to add 200. Doesn't even matter what's on the other side. As long as it's just a number, this is the plan. So we're going to first divide by 2. That will make this 2 go away. X minus 200 equals 30. Indeed, 30 is what doubles up to 60. Oh, I said we're going to divide both sides by 2. And now we don't need the parentheses anymore, right? And now what are we going to do? We're going to undo that subtraction by adding 200 on both sides. I have seen, this is American. Sometimes from Middle East, I see stuff like that. I think it's still something you don't need, but it's cleaner. That we're going to undo that by adding 200 on both sides. I think it's still too much writing, too cluttered. But it's less bad than this is the worst. Sorry. I know you might have, you know, attachment to your previous teacher who showed this to you, but that's okay. Keep the teacher, let this one go. And then we can check. 230 times 2 is 460. What? Oh, 230 minus 200 is 30. Double that, 60. So the left-hand side is 2 times 230 minus 200 is 2 times 30 is 60. Notice that I will no longer force you to do every single operation. It's not an order of operations problem. Just go as slow so you don't mess up. Notice we should be getting the same numbers, not just the same answers, but those intermediate numbers, as we're basically reversing those things. Even the checking, you just see the same numbers back over and over. Now that was on page 5. Okay. Solution. Okay. The next problem we did, maybe I should have done. I lost half of my money and then won $100. Walking out with 160. Can you write the two-step equation expressing this? Once upon a time, I walked in with X amount. I lost half of it and then won $100. Walk out with 160. What two-step equation expresses these sad sequence of events? No, this is the only happy one. This happy sequence of events. What two-step equation can we write? Perfect. Perfect. The perfect answer is in the chat box for all to see. Once upon a time, I walked in with X. First, I lost half of my money and then won 100. Now I'm walking out with 160. And so there are two things that happened, hence the name, two-step equations. Oops. And so you can ask, what happened to the unknown? We're going to undo those. We're going to undo what happened to the unknown in a reverse order. We will first in, last out. First in, last out, right? Or last in, first out, I guess. Last in, first out. I don't know if it's a separate, last in, first out. I think I heard this people, LIFO, in, first out. So the last thing that happened was addition of 100. We're going to undo that. We want this gone. We want to peel off all the extra stuff from X. So we want to undo those things that happen. Undoing this is a subtraction of 100. X over 2 should be 60, so that if I add 100, we will land on 160. Now what are we going to do? How do we undo that division? Is this the story? Yeah. We're going to multiply both sides by 2. And then this is the stuff I'm telling you to let go. This kind of, no, I mean, if you can decide what to do, that you want to multiply by 2, you already know that it's to undo this. You do not have to persuade yourself or the reader that undoing division by 2 is multiplication by 2. This is too basic to worry about it. You do not need to bring paper and ink into that. This is all you need. Sometimes less is more. Exactly. Well, yeah. And then people would say, oh, you multiplied 60 by 2, but this thing only works if we do the same thing to both sides. Now, yeah, 60 had to be doubled up, and in a way, X over 2 doubled up back to X. So the lack of this is where it manifests that we double that side. And let me check. 120 over 2 plus 100 is the left-hand side, which is indeed 60 plus 100 is 160. So we're good. Excellent. And then it might have been that moment when I said, wait a minute, let's keep the evens, just swap their orders. Wouldn't that be fun? No, this was the last thing. I'm looking for page 6. Page 5, page 6. Okay. I lost half of my money and then I won 100. That is reversing the 2. So I lost half of. No, it's the same thing. I'm sorry. It's the same thing, but now it's a sad story. It's the same 2 events. So undoing things in reverse. Okay, now here, let's work on this one. This is, I won 100 first and then lost half of my money. I'm walking out with 400. Because I want you to see the 2 of them together, how the swap in the order of operations will show up in the equation. So what equation can we write to translate this into an equation? Almost. The events are the same. So X over 2 plus 100 is first the division by 2 and then add the 100. I'm asking you to swap the 2. First win 100, then you lose half of your money. So multiplication should not be there. That's a very happy story because you doubled your money and then you won $100 and now you're walking out very happily with 400, right? Yeah, but why does, oh, that's a complicated thing what you're writing. No. Don't try to solve it. Just write down, translate it into an equation. So that X over 2 plus 100 equals 160 is perfect for the previous one. That's first division by 2, then add 100. How would you write them? Same, swap the 2 operations. Add 100, then divide by 2. How would that look like? Oh, there we go. That's the one. Only I see it, and it's not 100, but yeah. So instead of first divide by 2, then add 100, add 100, and when you're done, divide by 2. There is an invisible parenthesis there. That was actually visible when we multiplied. This is how you express add 100 and then lose half of that. And we walk out with 400. I don't know if to ask you to solve it again. So what happened is first an addition of 100, then a division by 2. We're going to undo those in the reverse order. So first we're going to multiply by 2 to undo that division, and then we're going to subtract 100 to undo that addition. Chop, chop, chop. So we're going to multiply both sides by 2. Oh man, he's not here. Not here. Then x plus 100 equals to 800. We literally had to double up the number. On the other side, the doubling is what made it come true what we wanted. We wanted to undo this. And now we're going to subtract 100. So x is 700. We check the left-hand side is 700 plus 100 over 2, which is indeed 400. 800 over 2. Any questions? Those of you who never chimed in into the chat box, you know that there is class participation points. Oh yeah, so there is a request in the chat box. You know, we're just going over the ones that we intuitively solved. So that is more, I think. This was page 6. It's the solution. There's one more, so it's perfect. Let me just cover up the. This is going to be a tough one to cover, but this one was, for some reason, some of them are easier, consistently easier for you to solve than others. Lost $300 and later doubled my money, walking out with 50. Solve it. Write an equation expressing it. Solve that too. Chop, chop, chop. Lost, yes, that's the one. So first I lost 300. Once upon a time, we had a number x. We lost 300. And when we were done with that loss, lost 300 and later doubled my money. So no. Oh yeah, so yeah, the correct answer is on the, I'm losing it. Walking out with 50. There we go. And it's not treated as a two-step equation, but it could be. That what happened to the unknown? Well, first a subtraction, and then a multiplication. So we're going to undo them in a reverse order. We're going to peel off first what was put there last by a division, and then we're going to add back that 300. So we're going to divide both sides by 2. Why? Because I want this gone. Divide by 2. And then we add 300 to both sides. Why? Because I want this gone. Now, the first one is so these three equations, there is a word for that. It's called equivalent. Oh, set. Okay, so when we write a second equation, as we solve an equation, an equivalent step is a step, is one that does not change the solution set. Do you hear the word set in there? That does not change the solution set. That's our favorite type of steps, and everything we have been doing today are equivalent steps. I'll show you a non-equivalent step. We try to avoid it as much as possible. I'm gonna guess page 9 here, page 10. So what is going on is that these three equations are all have the same solution set. But so that means that all three of them are conditional, true when x is 325, false for any other value of x. But that's not that obvious here. It's kind of obvious here. It's almost silly to, this one also declare almost a different kind of statement which declares let x be 325. But just think of it as a guess. Is x 325? So we're gonna make equivalent steps. Whenever we can, we stick with those, which means from one equation to the other, the solution set does not change. And what do we do? Why are we doing this step? Because we want to peel off that extra stuff. And we have to reverse things in a reverse order. That's just the way life is. These were all equivalent steps. Check this out. I'll show you a non-equivalent step. And those steps, we're going to try to not to do them unless we have to. And even then, there is going to be, there is a payment for it. It's not free. So x equals 5 is a conditional statement with just one solution. So squaring both sides is a non-equivalent step, because if you square both sides, this one now has two solutions. This one has one solution, 5, but this one 5 and -5. So guess what? Until it's going to be absolutely necessary, we're going to avoid squaring both sides of an equation, because it's going to give us equations of the last line, but not the first. So it's going to become essential that we go back and check. But for a long time, what is this, 98? Yeah, in this class, we're not going to have to square both sides of an equation. But basically, we apply equivalent steps when we add, subtract, multiply, divide, as long as you don't multiply by 0. If you multiply both sides by 0, you're just killing all the information. That's the only thing you're not allowed. Well, division by 0 is also not allowed. Everything else that we do with these basic operations is automatically an equivalent step. So as long as we do it to both sides, the solution set remains preserved. And so we manipulate both sides. How and why? Well, we want the complicated equation to look like this with the same solution set, right? So that's what it means to solve the equation. All right. I wanted to warn you and give you an example, but we ran out of time for the example. So just a warning, every time we learn some algebra, the word problems based on that algebra are automatically coming in. You have seen with the homework. So now you will see word problems that boil down to two-step equations. If I'll try to remember, but if I don't, can you please remind me on Wednesday to start with that word problems with two-step equations? All righty. So I'll stop here because we're out of time. Thank you guys, and I'll see you Wednesday. Thank you.